Hello everyone, welcome to the solution of LeetCode problem 162 named Find Peak Element. In this problem, we are given an integer array and we have to find the peak element. Here, a peak element is the element of the array where this element is strictly greater than its neighbor. Suppose in the first example, the element 3 is the peak element because it is strictly greater than its two neighbors 2 and 1. Similarly, in the example 2, the element 2 and 6 is peak element because they are greater than its neighbor. And according to the definition, here the leftmost element and the rightmost element, suppose for the leftmost element, its previous element is minus infinity, and suppose for this rightmost element, its next element is minus infinity. And in this problem, we have to find the index of the peak element and we have to return it. And here, a simple example can contains multiple peak elements. So we have to simply return the index of one of them. So we have to write an algorithm in big O of log and runtime. So this is the problem statement. I hope you understand it. Now let's move on to the algorithm. Now, this kind of problem can be easily solved using the binary search algorithm. At first, try to understand the intuition behind the binary search algorithm. Here, the binary search algorithm use two pointers. One is left, another is right. Left is pointing to the leftmost element, right is pointing to the rightmost element. Now, suppose we have to calculate the mid value. Here, the mid value is this. Now, by considering the mid value, in the next iteration, we can either look after the right subpart or we can either look after the left subpart. Suppose if we look after the right subpart, we can simply discard this left subpart and continue the binary search algorithm into the right subpart. Similarly, if we look after the solution into the left subpart, we can discard the right subpart of this array and continue look after the solution into the left subpart. But in this problem, it is quite tough to discard either left subpart or right subpart. Why it is? Because suppose this is our array and left is pointing to the first element, right is pointing to the last element, and suppose it is mid. Now, it can be possible that our solution or one of the peak element can be into the left subpart and another peak element can be into the right subpart. So, it is not wise to always discard one of the subpart because both of the subpart can contain solution. So, how can we optimize the binary search algorithm to solve this problem? Suppose let's understand or let's assume our initial array is monotonically increasing. Now, suppose it is the left pointer and it is the right pointer. And suppose it is the mid. Now, for this mid value, we can check that the next value is greater than mid and the left value is less than mid. So, in which direction it is optimal to search the solution? Obviously, the optimal direction will be the right part because in the right part, we can find one of the peak element. How can we do so? Because suppose we look after this element. Now it is greater than its previous element, but it is less than its next element. Now, for this last element, by definition, it is a peak if its previous element is less than it, because its next element is minus infinity. That's why the last element is greater than its both of the neighbor. Now, it is one of the scenario, or it can be possible that after going to the right part, after some element, then there will be an element which is less than the previous element. So if this kind of situation occurs, that means this element is the peak element. So here one intuition is always, if for the mid value, we have to look after into those sites where the value is greater than the mid value, because there is higher chance that the solution exists into this site. Now, is this intuition true for the monotonically decreasing array? Suppose our array is this. At first, let's try to erase all of them before drawing any of the figure. Now, suppose our array is something like this. It is monotonically decreasing. Now, our left pointer is pointing here. The right pointer is pointing here. And suppose our mid pointer is pointing here. Now, we can see that for this mid value, the next element is smaller and its previous element is greater. So, in which direction we will move? We will try to reach the solution into the greater side, because as this element is greater than the mid value, so it can be possible that the peak element exists into this side. How can we do so? If the array is monotonically decreasing, then the first element is the peak according to the definition. Because its previous element is minus infinity, so it is a peak element. Now, either it can be possible that after some of the previous element, there is a lower element. If this kind of situation happens, that means it is another peak element. So here, the optimal solution is, we will apply the binary search and we will look after the binary search algorithm into those sites where the value is greater than the medium value or the mid value. And by doing so repetitively, we can simply reach to the solution. Now, let's try to illustrate the intuition or the algorithm into this example. Suppose our left is pointing 2, right is pointing 1, and medium is 3. So here we can see that the next element 5 is greater than 3. So we have to look after into this portion. So we have to shift the left pointer here. Now, our left pointer is pointing 5 and right pointer is pointing 1. So what is the mid? Suppose, let's say, mid is pointing here. Now we can see that the value of the mid is 5. So here, 5 is greater than 3 and 1. So we can see that 5 is definitely greater than 1 and 5 is definitely greater than 3. So 5 is a peak element. If the peak is 5, then it is 3 and 1. So we can see that the medium element or the mid value appears into this value 5, which is a peak. So this is how the binary search algorithm works, and I hope you understood the algorithm. Now, the overall time complexity of this algorithm is big O of n log n, and the overall space complexity of this algorithm is big O of 1. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named find peak element, which has a vector as a parameter. Now we are taking 2 pointers, left and right, and running a loop while left is less than is equal to right. It is the binary search algorithm. Now here we are calculating the mid value, and if the mid is greater than 0 and the mid value is less than mid minus 1, that means the array is monotonically increasing. So here we have to run the binary search into the right subpart. Otherwise, if the array is decreasing, we have to look after the solution into the left subpart. Otherwise, we have to simply return mid. Finally, we have to return -1. If we cannot return anything into this binary search algorithm. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.